Good morning, everyone. I'm Sri Shakti Soumya, currently working as Senior Product Regulatory Compliance Expert in APA Engineering. Along with me, I have Riaz, Lead Product Regulatory Compliance. Today, we are going to take a webinar on carbon footprinting. Before we start the webinar, some housekeeping information. Everyone except speaker will be muted. It is recorded and will be shared afterwards. There will be a survey and question answer session at the end if time permits. As mentioned earlier, speakers are myself and Riaz. Before we start the carbon footprinting topic, I would like to introduce APA Engineering. We are 23 years old company. We have customers across the globe, US, Europe and Asia Pacific regions. And also we have ISO and TISAC certificate, and with this we try to get projects from different companies. We have 350 plus customers across the globe. As a company, we have 4 different kinds of businesses. In compliance, we deal with lot of environmental regulations for OEM and sub-tier companies. In engineering, we have customers on mechanical product development using several CAD, CAM, CS softwares. In sourcing, we ship the components across the different parts of the world. We have majorly 3 different models. One is compliance software developed by APA customers. Customers can purchase the software. We also provide service where customers can give up task-based services and turnkey solution. In turnkey, we take care of all the regulations that are applicable to their products. And we act as an extension of their in-house regulation team by managing all regulation applicable to their products. So this is the agenda for carbon footprint webinar. I hope all listeners get some useful information today by end of this webinar. So let's come back to the webinar. Now, let me give a basic definition of what is carbon footprinting and how it affects the climate change. It is commonly used to describe the total amount of carbon dioxide and the other greenhouse gas emission attributable to an organization, project, or product. There are various greenhouse gases such as methane, nitrous oxide, sulfur hexafluoride, perfluorocarbons, and hydrofluorocarbons. So next, how does carbon affect climate change? Carbon dioxide traps heat by both sun and the earth's surfaces and releases the heat into the atmosphere. As we burn fossil fuels and cut down forests, high concentration of greenhouse gases, especially carbon dioxide, threatens to raise the average surface temperature of the planet to intolerable levels and cause a life-threatening impact. Atmospheric carbon dioxide level have risen more than 40% since middle of the 18th century. As carbon dioxide level continues to climb, the temperature increases, then increased ocean acidification, rising sea level, more frequent and intense storm, mass species extinction, food scarcity, and greater economic inequality will be felt worldwide. So the world has come to agree to reduce these greenhouse gas emissions if we want to sustain future for ourselves. So collectively, different countries have agreed to reduce their greenhouse gas emission and have set a target to become net zero emission by certain year. So what is net zero emission? It is like cutting greenhouse gas emission to close to zero as possible, with any remaining emission reabsorbed from the atmosphere by oceans and forests, for instance. Currently, the Earth is raised already about 1.1 degrees Celsius warmer than it was in the late 18th century, and emission continues to rise. To keep global warming to no more than 1.5 degrees Celsius, this net zero target came into picture. More than 140 countries, including the bigger polluters like China, United States, India, and European Union, have set a net zero target covering about 88% of the global emission. And these are the net zero target and interim targets for various countries. Now, how do we achieve that target? And it is not only the country will do it, all the smaller entities within the country will have to reduce their greenhouse gas emission, and which is what all the companies are trying and they're working on it. How will they reduce the greenhouse gas emission? So now we'll discuss about global warming potential and what is carbon dioxide equivalent. Global warming potential is a term used to describe the relative potency molecule for a molecule of a greenhouse gas, taking account of how long it remains active in the atmosphere. Global warming potential currently used are those calculated over 100 years. Carbon dioxide is taken as a gas of reference and it is given as GWP as 1. Carbon dioxide equivalent are measured in million metric tons and it is used to compare the emission from various greenhouse gases on the basis of their global warming potential by converting the amount of other gases to the equivalent amount of carbon dioxide. So the example is, the equation is the carbon dioxide equivalent for a gas is derived by multiplying the tons of a gas by the associated GWP. So here are the GWP of the different gases. For example, GWP of methane is 25. This means the emission of 1 million metric ton of methane respectively is equivalent to emission of 25 million metric tons of carbon dioxide. You might get a question why we are mostly referring carbon dioxide as greenhouse gas and few terms like carbon equivalent. It's because all other greenhouse gases mentioned in the previous slides are more unstable and will break down into different compounds in atmosphere, whereas carbon dioxide stays stable in the atmosphere for more than 1,000 years, and that's why carbon dioxide is commonly declared as greenhouse gas. Source of carbon emission from your organization. We can split it into the two categories, direct emission and indirect emission. So direct emission is all the activities that your business controls, and just think of burning of fossil fuels in building vehicles. And then we have indirect emission. These are from activities that supports for your business operation, but they are outside of your control. So it is not your business directly burning those fossil fuels. Now we further break down these indirect emissions into two categories, upstream and downstream. So upstream is everything that your business purchases or requires. For example, electricity, because you pay the utility bill, you purchase that electricity. And downstream, which is anything related to the goods or services that your business creates or sells. Let me now walk you through the concept of scope 1, 2 and 3 emissions. Scope 1, 2 and 3 is the way of categorizing the different kinds of carbon emission a company creates in its own operation and across its wider value chain. Scope 1, which is burn, covers greenhouse gas emission that the company makes directly, for example, fuel burned while running its boilers, power generators and company vehicle, as well as the fugitive emissions such as leakage of refrigerants. Scope 2, which is by the emission that the company makes indirectly are scope 2. Lights, heating and cooling offices, computers, they all require electricity. The emissions that are produced by the power company to make your electricity. So accounts for your scope 2 emission. Scope 1 and 2 emissions are somewhat easy to control, for instance, by switching to renewable energy or to an electronic grid. Scope 3, which is beyond. This category covers all the emission associated indirectly to your company up and down your entire value chain. For example, the way your suppliers may source material to how a customer uses your product. 80 to 90% of the carbon footprint may be scope 3 emission. Scope 3 can be difficult to measure. There are various range of solutions in order to switch to the renewable energy sources such as solar, wind and water. As the world is facing climate change, and it is now important for the businesses to understand and manage their environmental impact. So key to this understanding is the accurate quantification of the greenhouse gas emission. GHG protocol provides an international standard for GHG measurement, which offers businesses to clear, comprehensive and consistent method of quantifying their emission within the scope 1. There are 5 steps for the calculation. First step in scope 1 emission calculation is the identification of the emission sources in every business operation that results in direct GHG emission. Scope 1 emissions can be divided into 4 categories: stationary combustion, mobile combustion, fugitive emission and process emission. Now let's move on to the step 2. The next step is to gather the relevant activity data, which is the key input for the calculation of the GHG emission, such as gallons of gasoline consumed from company cars. This activity data is collected in physical unit, gallons or energy unit terms. Step 3 is to determine the emission factor, which is used to calculate the GHG emission for a given source. Step 4 is to apply the calculation tool. There are varieties of calculation tool available in this link and we have to choose which is applicable. Step 5 is to roll up the data to the corporate level. This is the equation for the emission calculation and there are various sources to get the emission factors. Let's further discuss about the stationary combustion. This category includes emission that comes from the combustion of the fossil fuels. Sources of emission from stationary combustion includes boilers, combustion turbines, process heaters, incinerators. The most common fuels that fall under this area are natural gas, liquefied petroleum gas, oil, propane, etc. In this calculation, first we have to identify the source of emission. Second step is to collect the activity data. The activity data required for this calculation includes the amount of fuel consumed for each of the stationary combustion source and the fuel characteristics of each type of fuel used. Third step is to select the source either by the direct measurement or the purchase record. So direct measurement of CO2 emission is performed through the use of continuous emission monitoring system and purchase record in which the mass or volume of a fuel entering the facility. These data can be based on the fuel receipts, purchase records or data provided directly from the energy vendor or on customer online portal. Step 4 is to quantify emission. Calculate scope 1 stationary combustion emission using this link where different tools available in conjunction with the calculator. And also we can use other calculators like EPA calculator, UNFCCC calculators, which are available in the website. For example, I have used GHG protocol tool where I have entered the type and the amount of fuel. Last step is to ensure quality control. Now let's discuss on the guide to calculating scope 1 mobile combustion. This category includes greenhouse gas emission from the burning of the fuels of all the vehicles that are owned or leased by an organization. So step 1 is to identify the source of emission. Think of a road vehicle like company vehicle, trucks or a van, non-road vehicle such as forklift, construction equipment, rail, air, water vehicles that are fueled with petrol, diesel, gasoline, propane, etc. However, we have noticed the increase of electric cars in the past few years. So what about those? Well, fully electric vehicles and plug-in hybrid will fall into scope 2 emission, which is indirect emission. Second step is to collect activity data. GHG emission from mobile combustion are most easily estimated by collecting data on the amount of fuel consumed, distance traveled, vehicle characteristics and fuel characteristics for each identified source. Third step is to quantify emission, as mentioned in the previous slide for the stationary combustion calculation. Now let's discuss about the calculating the fugitive emission. Fugitive emission are the unintentional release leaks of greenhouse gases such as refrigerant gases or the gases from air conditioning unit. The global warming potential of these substances exceeds 1000 carbon dioxide equivalent, and hence even small emission can lead to the significant impact. Organizations are highly encouraged to report on these fugitive emissions. First step is same as like discussed previously, identifying the source. The common fugitive emission sources are refrigerated transport, industrial process refrigeration, cold storage warehouse, mobile air conditioning. Second step is to collect activity data. The activity data required to calculate fugitive emission depends upon the calculation approach selected in the step 3. Step 3 is to quantify emission. There are various calculators as I mentioned in the last 2 slides. There are 3 methods to calculate fugitive GHG emission from refrigeration and air conditioning equipment. So first method is the preliminary screening method. Estimation of emission from refrigerant, air conditioning and fire suppression equipment based on the type of equipment used and the emission factor. Use only if the fugitive emissions are relatively small. If emissions are estimated or believed to be relatively large, the company should use a more accurate and the robust method, as the emission factor used in this method are highly uncertain. So the activity data required for this method is type of equipment, number of units, refrigerants or fire suppressant used, total refrigerant or fire suppressant charge for the equipment. Sales-based method. For companies that maintain their own refrigerant equipment, emissions are based on the amount of refrigerant purchased and used by the facility. So the activity data required for this method are type of gas purchased, amount of gas purchased, and the purpose of the gas. So the last method is life cycle stage method, which is mass balance method. This method is recommended approach for equipment users who have contractor service their equipment. Fourth step is to ensure the quality control. So for all the scope 1 calculations, simple equation is to multiply the activity data and the emission factor to get the emission in tons. As discussed in the previous section, there are various online tools available for calculation. Now let's move on to the indirect emission, which is scope 2. As I told in the previous slide about indirect emission, which is scope 2 emission that occurs through the use of purchased electricity, steam, heat, and cooling, which can be delivered to an organization facility through a localized grid or through a direct line connection. Carbon dioxide, methane, and nitrous oxide are emitted to an atmosphere as fuels are burned to produce heat and power. So emission calculation in this depends on the amount of energy used and the mix of fuel that goes into producing this electricity. Scope 2 guidance from GHG protocol requires companies to use two reporting methods. One is location-based method. This method considers average emission factors for the electricity grid that provides electricity. Market-based method. This method considers contractual arrangements under which the organization procures power from specific sources such as renewable energy. So step 1 is to determine the amount of electricity that was purchased. So the utility bill or the other purchase records can be used to determine the amount of electricity purchased. If purchase data are not available for certain facilities or operation, an estimate should be made for the completeness. If the organization is one of many tenants in the leased facility and does not have the actual amount of electricity used in its space, the organization may estimate its consumption by multiplying the electricity purchased for the entire facility by the percentage of the floor area that the organization occupies. Step 2 is to determine the emission factor. This depends on either location-based or the market-based method. The following types are the location-based emission factors: direct line emission factor, regional emission factor, national emission factor. So for the market-based emission factors are energy attribute certificate, contracts, supplier specific emission factor, residual mix factor, regional emission factor, national emission factor. Each unit of electricity consumption should be matched with the emission factor appropriate for the consuming facility's location or a market. Step 4 is to calculate the emission. Multiply the electricity measured in kilowatt by the emission factor to get the GHG emission in tons. Multiply the global warming potential values by the GHG emission to calculate the total emission in carbon dioxide equivalent. It's time for the quick poll. Now I will hand over the webinar to Riyaz, who will give detailed explanation about scope 3.
Thank you, Shakti. I hope everyone has finished the poll. Please close the poll. Next slide. Very good morning to everyone. I am Riyaz, lead product regulatory compliance in APA engineering. I am going to explain about the scope 3 emissions, insights about its measurement and calculation. Before getting into the details, for those who are new to this topic, let me give the definition of scope 3 emissions. It is the result of activities from assets not owned or controlled by the reporting organization, but that the organization indirectly affects in its value chain. That's it. All indirect emissions not included in scope 2 that occur in the value chain of the reporting company. including both upstream and downstream emissions. So one has to build an effective communication and data exchange strategies with its supply chain and customers. Next slide, please. I'll talk about Scope 3 management. Before that, let me introduce the Scope 3 standard. The Greenhouse Gas Protocol Corporate Value Chain Accounting and Reporting Standard, referred to as Scope 3 standard, offers an internationally accepted method to enable greenhouse gas management of companies' value chains. According to this standard, there are 15 reporting categories. You need to quantify and report Scope 3 emissions from each category. And there are different calculation methods for all those 15 emission categories. To choose Scope 3 emission calculation methods, in general, more specific methods yield higher quality of Scope 3 emission data, whereas less specific methods yield lower quality of Scope 3 emissions data. The best method for each category depends on the factors listed below. It depends on the relative size of the emission from the Scope 3 activity, the company's business goals, data availability, data quality, the cost and effort required to apply each method, any other criteria identified by the company. Also, there are some practical approaches companies should take to reduce cost and complexity without compromising quality. Such approaches include choosing more accurate data and calculation methods for large contributors, and vice versa, means less accurate data and less accurate calculation methods for small contributors. Grouping and combining similar activity data, example goods and services. Obtaining data from representative samples and extrapolating the results to the whole using proxy techniques. Next slide, please. Before accounting for Scope 3 emissions, companies should consider which business goal or goals they need to achieve. You can see below the list of goals frequently cited by businesses. First one is identify and understand risks and opportunities associated with value chain emissions. It helps companies plan for potential regulations and can guide corporate procurement decisions and product design. Second one is identify greenhouse gas reduction opportunities, set reduction target, and track performance. This information may be used to identify the largest emission sources, that is hotspots in the value chain, and focus efforts on the most effective emission reduction opportunities, resulting in cost saving for companies. Next one is engage value chain partners in greenhouse gas management. With an effective management with a company's value chain, companies can identify the largest use of energy, material, and resource in the supply chain. This knowledge can help for cost savings through reducing material, energy, and resource usage. And the last one is enhance stakeholder information and corporate reputation through public reporting. Companies can improve stakeholder relationships through proactive disclosure and demonstration of environmental stewardship. Next slide, please. As I mentioned earlier, there are 15 Scope 3 categories. All those 15 categories are given in the table, and each of the 15 categories have different calculation methods. Table identifies all the 15 categories and a small description of the category and the minimum boundaries for each Scope 3 category in order to standardize the boundaries of each category and help companies to understand which activities should be accounted for. So the categories are purchased goods and services, capital goods. Next slide, please. upstream transportation and distribution, waste generated in operations, business travel. Next slide, please. Employee commuting, upstream leased assets, downstream transportation and distribution, processing of sold products, use of sold products, end of life treatment of sold products, downstream leased assets, franchises, and investments. Next slide, please. Screening to prioritize data collection. So this is a part of the scope 3 greenhouse gas management. So this scope 3 standard recommends that companies identify which scope 3 activities are expected to have the most significant GHG emissions, offer the most significant greenhouse gas reduction opportunities, and are most relevant to the company's business goals. In most cases, the categories that generate the largest amount of emissions should receive the most precise data collection treatment. However, some smaller categories that are important to customers or employees may also receive more precise treatment. Following criteria is used to identify relevant scope 3 activities. So it depends on size, influence, risk associated with emission, stakeholders, outsourcing, sector guidance, spending on or revenue analysis, and other. So these are some criteria which may trigger relevant scope 3 activities. So size, the activity contributing significantly to the total scope 3 emissions. So there may be some activity which will cause the largest amount of scope 3 emissions. So that is one criteria which has to be criteria for identifying the relevant scope 3 activity. Another one is influence. Any activity which can be influenced by the company. For example, companies identify an activity and it causes a lot of scope 3 emissions, but companies can easily influence to stop or reduce the emissions. Such kind of activity. So such kind of activity is considered as relevant scope 3 activity. Risk. The activities poses risk related to climate change, financial, regulatory, or reputation. So any activity which causes some regulatory requirement or some reputational risk for the company, it affects the reputation of the company. In such cases, this risk is considered as the criteria to choose the relevant scope 3 activity. Stakeholders, due to the influence of customers or society or investors. An outsourced activity. Sector guidance means they have been identified as significant by sector specific guidance. Spending or revenue analysis. Sometimes high levels of greenhouse gas emissions are correlated by the areas having high levels of spending or generate high level of revenue. Any other criteria, they meet any additional criteria developed by the company or industry structure. Next slide, please. Calculating emissions requires the use of two types of data. So I'll be explaining about those two types of data in the slide. Those are, the first one, two types of data, that is activity data and emission factor. Activity data is a quantitative measure of a level of activity that results in greenhouse gas emissions. For example, liters of fuel consumed or kilograms of material purchased. An emission factor is a factor that converts activity data into greenhouse gas emissions data. For example, kilogram of CO2 emitted per liter of fuel consumed, or kilogram of CO2 emitted per kilogram of material produced. To calculate emissions associated with a material or product, two types of emission factors can be used. First one is life cycle emission factors, which includes emissions that occur at every stage of a material or product's life, from raw material acquisition or generation of natural resource to end of life. And the second one is cradle to gates, sometimes referred to as upstream emission factors, which include all emissions that occur in the life cycle of a material or product up to the point of sale by the producer. In general, cradle to gate submission emission factors should be used to calculate emissions associated with goods or services. To calculate energy emission factors in Scope 3 accounting requires two types of emission factors to convert energy activity data into emissions data. First one is same as for material or product, that is life cycle emission factors, which include not only the emission that occur from combusting the fuel, but all other emissions that occur in the life cycle of the fuel, such as emissions from extraction, processing, and transportation. The second one is combustion emission factors, which include only the emission that occur from combusting the fuel. Next slide, please. So there are two types of data, primary data and secondary data. Primary data includes data provided by suppliers or others that directly related to specific activities in the reporting company's value chain. Secondary data includes industry average data. Example, from published databases, government statistics, literature studies, and industry associations, financial data, proxy data, and other generic data. So primary data has to be taken from the supply chain, and secondary data can be taken from the public sources, government sources, or any other such sources. Primary activity data may be obtained through meter readings, purchased records, utility bills, engineering models, direct monitoring, mass balance, stoichiometry, or other methods for obtaining data from specific activities in the company's value chain. But when collecting secondary data, companies should prefer those that are internationally recognized, provided by national governments, or peer-reviewed. Secondary data sources can cover different stages in the value chain. Care should be taken to understand the boundaries covered by the data to minimize the potential for double counting errors across the value chain. The greenhouse GHP protocol website has a more comprehensive list of secondary data sources. You can see the website address in the slide. Next slide, please. Greenhouse gas accounting and reporting allows companies to track and report their emissions performance over time. Companies may track Scope 3 emissions in response to a variety of business goals, including demonstrating performance towards achieving greenhouse gas reduction targets, managing risks and opportunities, and addressing the needs of stakeholders. A company should follow below steps to track Scope 3 performance over time. Choosing a base year and determining base year emissions, setting Scope 3 reduction goals, recalculating base year emissions if necessary, accounting for Scope 3 emissions and reductions over time. And when a company chooses to track performance or set reduction target, companies should act as below. Choose a Scope 3 base year and specify the reason for choosing that particular year. Develop a base year emissions recalculation policy that articulates the basis for any recalculations, and recalculate base year emissions when significant changes in the company structure or inventory methodology occur. Next slide, please. Scope 3 reporting. A credible greenhouse gas emissions report represents information based on the principles of relevance, accuracy, completeness, consistency, and transparency. It should be based on the best data available and be transparent about its limitations. Companies shall publicly report the information listed below. So of course, Scope 1 and Scope 2 emissions report in conformance with the GHG Protocol Corporate Standard. Then total Scope 3 emissions reported separately by Scope 3 category. For each Scope 3 category, total emissions of greenhouse gases reported in metric tons of carbon dioxide equivalent, excluding biogenic CO2 emissions and independent of any green GHG trades such as purchases, sales, or transfers of offset or allowances. A list of Scope 3 categories and activities included in the inventory. A list of Scope 3 categories or activities excluded from the inventory with justification of their exclusion. So, as I explained earlier, there are 15 Scope 3 categories where potential emissions. We have to categorize emissions into those 15 categories, and each 15 categories have different calculation methods, and each calculation method have an equation for calculating emissions for each category. I have not explained those calculations in this webinar because this time is not sufficient to explain all those calculations. We'll be conducting another webinar where we'll be solely explaining the calculation of Scope 3 emissions in 15 categories with practical examples. So next one is, once a base year has been established, the year chosen as the Scope 3 base year, the rationale for choosing the base year emissions recalculation policy, Scope 3 emissions by category in the base year, consistent with the base year emissions recalculation policy, and appropriate context for any significant emissions changes that triggered base year emissions recalculations. For each Scope 3 category, any biogenic CO2 emissions reported separately, a description of the types and sources of data, including activity data, emission factors, and global warming potential values used to calculate emissions, and a description of the data quality of reported emissions data. For each Scope 3 category, a description of the methodologies, allocation methods, and assumptions used to calculate Scope 3 emissions. The percentage of emissions calculated using data obtained from suppliers or other value chain partners. So today, that is the end of the webinar. That's all we have. Today we have covered an overview about the guidance on how measurement and calculation of Scope 1, Scope 2, and Scope 3 emissions is done. Hope you have some takeaway from this session. Thank you for your valuable time and joining us. We have a question and answer session now. Please type all your question in the chat box. We'll answer if time permits, or we'll send you the answers in email. You can also send your questions in the email ID compliance@apaengineering.com. Please take a screenshot of this slide and send all your questions related to carbon footprinting. Not only this, if you have any doubts related to any other regulations also, please reach out to this email ID. We'll be replying within short period of time. You can type in your questions in the chat box. So we have 1 more minute. Please type in your questions in the chat box, or else you can also send your questions in the email provided in the slide. We'll be answering those within short time. Okay, thank you everyone. Time is up. Thank you.